Hello guys, this is the third video from the factorization videos that I have been sending, and this is basically the last one. I hope that it hasn't been that difficult for you, and it is a review for many. Okay, so just reviewing what we have already seen, the common factor where we took off a like term or a like element from each term. We have seen also the difference of squares with the origin of conjugate binomials, and the difference of cubes and sum of cubes, which involve a binomial times a special trinomial. But today we're going to continue moreover on perfect square trinomials and other type of non-perfect square trinomials. But starting with this one, a perfect square trinomial is the result of a square binomial, okay? So remember that everything that we're doing right now, we're going backwards from the multiplication scheme, okay? So if we have a form of a squared plus 2ab plus b squared, we take off each of the roots from a and from b because they originated from a square binomial, okay? And the same thing happens with the negative square binomial. Okay, so now I am writing the non-perfect square trinomial. So what happens when you identify a trinomial that doesn't obey to the form of a squared plus or minus 2ab plus b squared? Well, we will find it in a form of either a leading coefficient 1 or not a leading coefficient 1. What do I mean by that? If the first term is alone or by itself, if it starts in this form like x squared plus bx plus c, okay? That the first leading coefficient is a number 1 and it's not another number, okay? So the factorization of this type of trinomial would be two different binomials where you obtain two numbers that when multiplied you give you c, and that when you sum them up they give you b, okay? So I'm writing here like multiplied and summed up, okay? But this can be put in a formal notation. I'm just gonna write it so that you have the notes. But in real practice, you use the rule of thumb of considering if you multiply such and such, you get the third term. If you sum up these two numbers, you're gonna get the in-between number, okay? It's not necessary for you to learn the formal notation, but rather understand it, which is the basic part of everything that we do in math. So now we're going to proceed to the next type, which is also a non-perfect square trinomial, but in this case it will not start with a number 1, okay? So the leading coefficient won't be 1, but it will be any other number, okay? And the factorization would be very different, and we will see further on the examples. But for now, let me write you the form so you can have the theory, and it would be ax squared plus bx plus c. Okay, so as you see, it's very similar to the one before, but having an a number in the leading coefficient, okay? Formal notation, I'll leave it here for you, would be a pq x squared, and then we have the sum of these other terms plus mn, okay? So this just means that you have to find some numbers that when multiply them and summed up, they give you what's in between. There I am writing what each term would form from the original trinomial, okay? So many times many letters confuse, so we better move on to the examples, okay? So let's start with the first example. The first example would be of the perfect square trinomial, okay? We have an x squared minus 6x plus 9. So it's very important for us to identify three elements, okay? First, checking if they are the first and the last have square roots. if the middle term complies to the 2ab form, and if the sign of the third term is a positive sign. It would always be a positive sign because it is a squared number. Okay, so x squared has a root, 9 has a root, and the one in the middle, 6x, is the multiplication of both of the squares, x times 3 times 2. Okay, therefore we could write it as the root of the first, the root of the last, the sign, and it would be an x minus 3 squared binomial. Okay, now moving on to the next example, it would be an example of a non-perfect square trinomial with the leading coefficient 1. Okay, so the procedure of this type of trinomials, it's just first identifying that you're gonna proceed in such a way. Here I am writing it x squared minus 8x plus 15. So always check which case applies. It's not a common factor, it's not a difference of sum of cubes or of squares, but it's rather a trinomial that obeys to this type of form because it's not a perfect square trinomial. So you write x and x, okay? And then the sign of the first one and multiplication of the first and the second sign, okay? And then find two numbers that multiplied give you the 15, and that summed up they give you the 8. So that would give me 5 and 3. And always place the number that's larger in the first one, okay? Because if you obey the signs that I told you, that you put first the first sign and then the multiplication of signs in the next parenthesis, when you put the larger number first, it would make sense, okay? So that's like just a little trick, okay? And last, we're gonna see the example of the non-perfect square trinomial, but when we have a leading coefficient that is not 1. Here the procedure is a bit larger because you have to split the middle term into two different terms. So here comes the example. It's 3x squared minus 10x minus 8. Okay, so the first step will be multiplying the first and the last term. So 3 times minus 8 would give me minus 24, okay? Now, I need to find two numbers that when they are multiplied, they give me minus 24, and that when I sum them up, they give me the minus 10, okay? It is very similar, but slightly different to what we have used before. So I'm writing here a line for each of the 4 terms that I tell you that we have to have at all, because I'm gonna split the middle term. So these two numbers would be minus 12 and plus 2, okay? So remember, we're splitting that minus 10x, and it makes sense. I have the two numbers that multiply them give me minus 24, and that if I sum them up, they give me that minus 10, okay? Why did I split this middle term? You're gonna see now why. The next step that we have to do here is group, okay? So there is a type of method that we group certain terms in order to obtain what we can factor, okay? So this is called a grouping method. So from the first two, we can identify that they have a common term, okay? Just think about what that common term can be. And the second ones also have a common term. So what is their common term? From the first one, we can identify that 3x is their common term. And if we factor out that, it would be x minus 4. From the second case, it would be 2. We can just factor 2, leaving us another x minus 4. Now hold on. We have just found out that they both have this x minus 4 term, okay? So a binomial can also be considered a term. So we can factor that term out. It would be x minus 4 times the other left numbers, which are 3x plus 2, or we could write them in an ordered form. The order of the factors does not alter the product, okay? So there you have it, okay? And that's the complete factorization of all of these examples. So recap on this third one. Remember, the first thing is to multiply the first and the last. Now, the second one is that when you can find the ones that are multiplied and summed up, you have the 4 terms, then grouping, then factoring, and just writing that numbers out, okay? See you tomorrow, guys.